should be very easy. Let me number these to help out. Okay, number 1, what do you think? True or false? Segment AB and segment HG are coplanar. We haven't really gone over this vocab in a while. Good. That is false. What are they? They're skew. And by definition, skew lines are non-coplanar. Very good. Okay, number 2. IJ, and AF. IJ and AF are skew. True or false? So remember, this is when we're limited by the smartboard and by a screen. It looks like those green segments are intersecting. I see them cross. But we do realize that AF is in front and IJ is behind because it's three-dimensional. And so they are not in the same plane. They are skew. True. ED and IG are coplanar. ED and IG. Go. What's the answer to number 3? Oh, good. It's working. Okay. So just because they're not in a plane that represents the face of your figure, like, no, it's not in one of the faces. It's not in one of the planes I could touch on the outside. But they are coplanar because they both lie in this plane right here. So they're parallel, and by definition, parallel segments have to be coplanar. They're always coplanar. Number 4. Tomorrow. Number 4. Stop clicking the cameras. Number 4 is one of those where I could erase the picture and you could still answer the question. You don't even need a figure to answer this question. I, H, and C are coplanar. We learned that any 3 points are coplanar. Any 3 points are coplanar. So it was false. True, true, true. All right, let's go over our homework answers. See if you can read those. 5, 6, square root of 13, scalene. The shortest side is 5, the longest side is 10. This one down here says 36 miles. Number 4, the answers are B and D. Number 5 was just kind of a different problem. The teacher that typed up the answers wrote, when you square a negative, it becomes positive. There's a lot of different answers you could have put for that one. Number 6 is 2 and negative 4. Number 6 is just like the warm-up from yesterday. And number 7 is 40. So, which ones do you want me to talk about? All right, I'm going to go over number 3 first. So, in number 3, first we notice that we have a quadrilateral because we have a fence and it's going around 4 posts. So, we're going to have 4 sides to some sort of figure. So, it has 4 sides. So, if we want to find how many miles he would drive around the border, this is a key word that we're looking for, perimeter. So to find the perimeter of a quadrilateral, you find the length of 4 sides and you add them up. So we're going to be using the distance formula 4 times, or not. So let's take a look at this. We know that we need to find the distance from A to B. Now, before I start going crazy and drawing my big radical with all that stuff inside, I noticed something immediately about coordinate A and coordinate B. And I noticed that they have the same Y value. You know what that means? Segment AB is a horizontal segment. That's what it is. It's just a horizontal segment. And so if I wanted to find the distance from A to B, I really only have to find the distance between 6 and 16. Because if I were to do the distance formula, squared, that 5 minus 5 is 0. That's going to cancel. So I don't even need to use the distance formula. I am finding distance on a number line. It's not a 2D distance, it's a 1D distance. So I just do 16 minus 6, and I get 10. So driving from A to B, it's 10. Okay, let's see if we get lucky again. Let's drive from B to C. Oh, look, B and C, the x value is 16 for both of them. So this one's a straight up and down segment. It's not diagonal, it's straight up and down. So I really only need to find the distance from -4 to 5. Remember, you subtract every time. 5 minus -4, or the other way around, and you get 9. Okay, now let's do from C to D. Oh, I got lucky again. The -4's match, so the distance from 16 to 6 is 10. And now I can kind of tell that I'm dealing with a rectangle because the opposite sides are congruent, but I'll do the last one just in case. It could have tricked me and been something else. So from D to A, let's see, the 6's are the same, so I just need to find the distance from -4 to 5, and it's 9 again. So then you just add them all up, 10 plus 10 plus 9 plus 9. Okay, so moral of the story. The key was wrong. Teachers are humans. We make mistakes. The answer was 38 the whole time. So, sorry about that. The answer's 38. And now, just in case you didn't know how to do it, now you know how to do it, but you probably weren't asking me how to do it. Okay, the answer to number 3 is 38. Number 6, I'm going to do number 6, but I'm not going to go too far in depth because we already did it for the warm-up the other day. So I'm going to do number 6, but I'm going to do it pretty quickly. We're going to start with our Pythagorean theorem template. And we're going to do circle my x's and underline my y's. The order that you put it in doesn't matter, so I'll put my underlines in, and I'll put my circled ones in, and then I already know that it equals 5. Okay? I'm going to clean it up a little bit. This is the square root of, well, 4 minus 0 squared, okay, so that's just 16, and then a minus a negative is a plus. Okay? The next step is to do the opposite of what's being done to x. We need to get the square root away, so we are going to square both sides. The square and the square root are going to cancel. So this and this cancels. So we have 16 plus x plus 1 squared equals 25. I did not touch what was under the square root. I didn't square the stuff underneath because it canceled out. I'm going to move the 16 over by subtracting it from both sides. 25 minus 16. Alrighty. Now I need to do the opposite of squaring. I need to get rid of that squared. So the way I'm going to get rid of it is I'm going to combat it with its opposite. I'm going to square root. This and this cancel. So we have x plus 1 equals, and remember, when we square root both sides, we get 2 answers. No, not plus or minus 9. I'm sorry. 3. I got it. Sorry. I was working too fast. Plus or minus 3. So there's going to be 2 answers. So we set x plus 1 equal to 3 and x plus 1 equal to negative 3. When you solve both of those, you will get 2 and negative 4. Okay, that's all I'm going to say about that. All right, let's do some practice problems. EB is parallel to what segment? EB is parallel to what segment? Good. So if you were to use the correct notation, which I know you can't use when you're typing, you would do capital H, capital C with a segment on top. So EB is parallel to HC. Very good. If they're parallel, are they coplanar or non-coplanar? They're definitely coplanar if they're parallel. They're definitely coplanar. Good. Name the intersection of EB and EBD. Sorry. Okay, y'all don't have to raise your hand anymore because they're all showing up on my screen. B. The answer is B. You could kind of tell from this right here that they both had B in common, but you needed to check the picture to make sure that those weren't overlapping. But EB, where does it intersect BD? That's also like saying what points do those segments have in common? And the point is B. How many lines contain point B? So in the picture, there's one line drawn that contains point B, but we know that there's an infinite number of points, an infinite number of lines through any given point. So the answer is infinite. Very good. How many lines contain point A and point B? When I change it from 1 point to 2 points, how many lines contain point A and point B? The answer is 1. Because one of our postulates say through any 2 points, there's exactly 1 line. So the answer is 1 to this one right here. Name that line. Let's name it. I could name it AB. I could name it football, FB. I could name it BF. You get the idea. So you can name a line picking any 2 points from the line. Or the cursive letter, but there's no cursive letter for that one. List 3 points that determine plane K. 3 points that determine plane K. So we have to be careful on this one. It didn't say list 3 points that lie in plane K. 3 points that determine plane K. So you can list any 3 points in that plane, but you can't list, here would be some wrong answers. This would be a wrong answer, bad, and this would be a wrong answer, bad. Why am I not allowed to answer with those answers even though those points are all in plane K? Good. Those points, to me, it looks like they might be collinear. So remember, if you're going to determine a plane, it has to be 3 non-collinear points that determine a plane. Any other points that you named would be correct from there. Any other ones would be correct. I thought you said that 4 points can't be coplanar. 4 points can be coplanar, but that's a sometimes. That was on your quiz. That's a sometimes. Sometimes 4 points are coplanar. Name 2 points that determine line L. A and G. Ooh, sorry for that. A and G. Very good. Very good. How many planes contain segment BF? Or FB? How many planes contain segment FB? 20? Some said 2, some said 20, and some said infinite, and some said 3. Oh, goodness. It is an infinite number of planes. It takes 3 points to make a unique plane. Segment FB it only takes 2 points to make a line. So you could take a plane through any 2 points, and you could put a million planes. This plane, this plane. You can rotate your plane. You can pivot your plane. I'm pivoting my plane, and I still have this line. So through a line or through a segment, there's an infinite number of planes. So in the picture, there's only 2 drawn. But could I keep drawing planes at different angles that contain FB? Absolutely. So the answer was infinite. Name the intersection of line L and FB. Good. Good. Okay, we're going to skip the draw ones, and we're going to go into a counterexample one. Try this one. So it said, show that the statement is false by providing a counterexample. So it didn't say if if it's true or false. It says it's already false. Now give me a counterexample. So the answers would be January or February. Remember, a counterexample is just one word, usually, or one picture. It's not a whole sentence. So your answer could have been January or February. Yes, if your bell rang, you can go. Yes. If a number is divisible by 7, then it is odd. 14. Very good. So we want a number that is divisible by 7 that's not odd. So we would want an even number. 14, 28, 42. Yeah. The sum of 2 numbers is greater than either number. Ooh. The sum of 2 numbers is greater than either number. Provide a counterexample. You're saying when one of them is negative. So you would probably need to give the actual 2 numbers. So I'm going to give 2 numbers, okay? -1 and -7. Let's try it out. The sum of 2 numbers, so let's add them up. The sum of 2 numbers is the answer greater than either number. No. In our example, it's less than those numbers, so we proved it wrong. We added 2 numbers, and the result was not bigger. It was less than. Very good. You could use 0, and you could use negative numbers to do that one. All right, we are done. You're going to work on your review. Your assessment tomorrow is over distance. Distance using the distance formula or distance using Pythagorean theorem. All right?